I'm Camillle Schrier, and I have a degree in biochemistry and systems biology, and I'm currently pursuing a Doctor of Pharmacy. But I'm also Miss America 2020, and I've teamed up with 3M to bring you a simple at-home science demonstration that will teach you all about diffusion. Okay, so picture this. You're coloring a picture with some markers. You start coloring and two different colors start to touch. And when they touch, they start to bleed together and the colors start to move through each other. Or what about this? You're in class, and if all of you have the option to sit around the room, are you all going to sit together at the same table? Or are you going to each distribute at all of the different tables in the room? So these are the kinds of things that we're thinking about when we're looking at diffusion. Diffusion is the mixing of substances based upon the movement of their particles. This can happen with all different types of matter, but it usually happens in liquids and gases. Usually diffusion has two things, a rate and a direction. The direction of the diffusion is typically from a high concentration to a lower concentration, and the rate of diffusion depends on how fast the particles are moving. And so there's lots of different things that might affect the rate of diffusion, but today we are going to be looking at how the temperature of a liquid affects its rate of diffusion. So this is really simple. All you're going to need is 2 clear glasses, some water, and some food coloring. So I'm going to take these 2 glasses and fill them up with different temperatures of water. I'm going to fill them about halfway full, and I'll be right back. So I filled up my 2 clear glasses about halfway with tap water. And this glass I filled up with the hottest tap water I could get. And this one I filled with the coldest tap water I can get. And now what I'm going to do is put a drop of food coloring in each of them. And I'm going to do my best to do it pretty much at the same time so we can compare the rate of how fast this diffuses within the water. Ready? Okay, so let's watch these and see how the rate of diffusion compares. So you've let your glasses of water sit for a few minutes, and you should be able to tell that the diffusion happened faster in your glass of hot water than your glass of cold water. But when we put the water in the glasses, they looked exactly the same. So what's the difference between hot water and cold water? The food coloring mixes more quickly through the hot water than the cold water because it has more energy. And we can't see the energy when we look at the hot water, but on the molecular level, the molecules of water are moving around much faster in the hot water than in the cold water. And so if those molecules are moving around much faster in the hot water, that's what's going to bring the dye around the solution much faster. And that is why the rate of diffusion is higher in that hot water, because the molecules are moving around really quickly and bringing the dye with them. When we put that drop of dye into the glass of water, that is highly concentrated. And my clear glass of water is, of course, a very low concentration of dye because it doesn't have any. So when we put that drop of dye in, that high concentration meets an area of lower concentration, so it wants to spread out and diffuse. So when we watch our glasses and we watch that blue dye find its way into all of the corners of the glass, what we are actually seeing is the dye moving from an area of high concentration to an area of lower concentration. So if you're interested in learning a little bit more about diffusion, here are some wonderful questions that you can explore. In this experiment, we used the same temperature of food coloring in both of our glasses of water. Can you find a safe way to heat and cool your food coloring? And can you predict how it might change the rate of diffusion in each of your glasses of water? And where are some other places in your life that you see diffusion happen? Have you ever made coffee or tea? Do you think this plays into why coffee and tea are made with hot water? So try the opposite and observe any changes in your results. When you're done exploring diffusion, make sure to clean up. You can take both of your glasses of water, pour them down the sink, and make sure to wipe up any spills and put away your food coloring and materials when you're done. Thank you for watching, and I hope that I was able to diffuse a little bit of new knowledge into your minds. And remember that science really is all around us.